Okay, last section of notes for the 2020 school year. Huzzah! All right, so circles in the coordinate plane. What does the equation of a circle look like? Well, that's what we're going to be able to figure out. Let's start by graphing a circle with a center of 3, 2. All right, so 3, 2 is going to be 1, 2, 3, 1, 2. All right. And then, all right, so we have a center of 3, 2, and then we have a radius of 4. All right, which points can you plot that are completely accurate on here? So if we have a center of 3, 2, and a radius of 4, that means we should be able to go 4 in any direction from this point and be able to figure out what our circle is. But like we can't go diagonally, so we can really go only left, right, and up and down. So if we go right 4, 1, 2, 3, 4, we are at this point. So if you count 1, 2, 3, 4, 5, 6, 7, and then 1, 2, I'm going to label this point A. So A is 7, 2. All right, then let's go 4 to the left. 1, 2, 3, 4, and we're going to land over here. So now we're at -1, +2. I'll call that B. All right, notice when we do this that we didn't change the y value at all. So when we are going like left and right, all that's getting changed is the x value. So you're adding 4 to this x value, you're adding 4 to this x value, and then the y values are just staying the same. But now when we go up and down, so we can still have a radius of up, 1, 2, 3, 4. Now we're going to be at 3, 1, 2, 3, 4, 5, 6. And we'll label that point C. And you'll notice the same thing is happening over here. Now the x stayed the same for the center, but this guy got added 4. And then if we go 4 down, 1, 2, 3, 4, now we're at 3, -2. And again, the x value stayed the same and we were just subtracting 4. So even if you don't have graph paper for this, you can still figure out what those 4 accurate points are just by adding 4 and subtracting 4 to the x's, adding 4 and subtracting 4 to the y's. So I'm going to attempt to draw a circle without a compass. All right, it's not bad, not perfect, but not bad. All right, so what is always true about this circle? Well, this circle is always going to have a center at 3, 2, and a radius of 4. That's just all we can say is always going to be true about the circle. All right, using this information and our good old friend, the distance formula, you remember that guy? Oh yes, he's back. All right, we can create the equation for a circle. So that's what we really want to know about this guy. So what we're really trying to do is say like, okay, so our center is 3, 2 over here. But say it's like, I want to know what this radius is, but I have no idea what this point is. All right, so we're going to use this point and our center to figure out what it is. But first, before we can plug anything in, let's remember what our distance formula actually is. All right, so your distance equals the square root of the difference of your x's, so x minus x, and then squared it, plus the difference of your y's squared. All right, so that's our distance formula. And we are going to use our center point and this random point that I just chose on the circle to see what our equation of the circle is actually going to be. So the distance we know, this radius we know is going to be 4. So the distance is 4. We still have the square root. Now we have, we're going to start with this x just because that's how the formula kind of goes. So we have x minus this x, which is 3 squared, and then plus y minus the y of our center squared. Okay, but now formulas usually don't have square roots in them, so we are going to square both sides. So now 16 equals, these guys cancel each other out, just x minus 3 squared plus y minus 2 squared. This is the equation for a circle. More often than not, you see it kind of flipped around. So you see the x's first, and then you add your y's, and then you have this number. But regardless, either way, both of these count as the equation of a circle. All right, so what can we know about the equation of a circle now? So just looking at these guys, okay, what's in our equation? So obviously, hopefully you see that our center point is in there. So we need a center point. We call it h and k. Those are usually the variables that we use for this. And then we have our radius that was in here somehow. But now our center point was +3, +2. And in our equation, it's -3 and -2. So when we plug it into our equation of the circle, it's always going to be subtracting whatever your x value is and subtracting whatever your y value is. All right, so they're always going to seem opposite than they do in your center. So if you had two positive x and y values over here, they're going to seem negative or opposite inside your equation. And then notice how 16 was not our radius. So the equation of a circle is always going to be whatever your radius was squared. So that is our formula for any equation of a circle ever. So your h's and k's are always going to appear opposite that they do in your center. You always have to have these squareds on the outside. You're always adding these, just like in the distance formula, and it's always going to equal your radius squared. All right, so let's actually put this into practice a little bit. So we have a center of 5, 3, or -5, 3, and a radius of 3. So we're just going to plug it into here. I'm going to show all my work for the first view, and then hopefully once you begin to understand a little bit, you can start taking some shortcuts. So we are going to have x minus the x value of my center. So that is x minus -5, and then I square that, plus y minus the y value of my center, which is -3. And then my radius is 3, and I'm going to square it. So what's the actual equation of this circle? Hopefully you guys know you can never leave minus and negative, so it's going to turn to positive. So it's always, always, always going to look like the opposite of whatever h is inside your equation. So if you have a -5 in your point, you're going to have a +5 in your equation. And then likewise with the y. So now I still have y minus 3 squared. I had a positive 3 in my center, so that means I'm going to have a -3 in my equation. They're always going to change signs because of those little negatives over there. And then 3 squared is just 9. So this is my real equation of my circle. Okay, I'm going to show my work one more time over here. So over here, I have x minus 0 squared, and then y minus the y value, 2 squared, equals the square root of 6 squared. So what is that going to turn into? Whenever we have x or y minus 0, it's not going to make a difference. So we just have x squared, because x minus 0 is just x. And then plus y minus 2 squared. And then the square root of 6 squared, these guys are inverses, they undo each other, so it's just going to be 6. All right, now for this one, let's just take our shortcut, even though this one's pretty easy anyway. So for this one, we are just doing x minus x of the center squared, and then plus y minus this y value of the center squared equals 1 squared, which is just 1. So that's it. So both of these were positive. They're going to show up negative in here, and then you're just squaring this, which is 1. That was easy enough. All right, the last one. Again, if our center is 0, 0, whenever we're subtracting 0, it's just going to be x squared. So really what's going to happen over here is we're just going to have x squared plus y squared, and then equals the square root of 16 squared. Again, the square root and the squared cancel each other out, so it's just going to be 16. And just like that, we are done. All right, let's go on to the back side. We're going to go opposite. We're going to be given a picture of a circle, and then we have to figure out what the equation is. All right, so in order to write the equation given a picture of the circle, we just need to figure out two things. What is the center and what is the radius? So our center over here is just -1, -1. And our radius, I just always go to the right, 1, 2, 3 to get to the end. So our radius is just going to be 3. So what is the equation of our circle going to be? So again, I'm going to just take the shortcut. So when I have x, I'm subtracting the x value, x minus -1, but I know it's always going to be the opposite. So I'm going to go straight to x plus 1. And then we always add in the middle, y minus -1 again, or just the opposite of whatever sign that is. It's going to be y plus 1. And then my radius has to be squared. So 3 squared is 9. And that's the equation of this circle. All right, the next one over here, what is our center? 1, 2, 3, and then -1. So our center is 3, -1. Our radius, 1, 2, 3, 4 to get to the end of the circle. All right, so we always want the opposite. So since this is a +3, I want a -3 in here, square it, always add in the middle. And then with the y's, I want the opposite of this guy. So it's going to be y plus 1, square it, and then 4 squared is 16. Done and done. Oops, you can't see that 16, but it's there. All right. So now, and again, pause if I'm going too fast. Make sure it's registering in your brain. All right, the last one. Name the center of the circle and the radius of each circle. So now they're giving us the equation and we have to pull it out. So remember, our center is always going to be what's inside with the x's and the y's. However, it's always going to be the opposite of whatever sign it looks like over here. So since we're subtracting 1, it's going to be +1 inside here. And the x obviously goes in the x spot. What numbers with the y obviously goes with the y spot. So since we're subtracting 2, it's going to be a +2 in here. Because remember, the formula says x minus whatever the value is. So x minus +1 is x minus 1. If this was +1, we would have to have x minus -1. So it's always going to be the opposite. So the quicker you remember that, the better. All right, and then we have to know that this is not our radius. This is our radius squared. So we have to take the square root of this, which is just going to be 3. Okay, and then it says to graph the circle. So our center is at 1, 2. And then we have a radius of 3. So we have to have the 4 accurate points on each circle. So you're going to go 3 to the left. 1, 2, 3. 3 to the right. Freeze. Everybody clap your hands. I'm just kidding. All right. I know you missed my corny jokes in class, so there you go. All right. So anyway, so then we're going to name these points. So 3 to the left, which just means I'm subtracting 3 to 1. So that's going to be -2, and my y stays the same. 3 to the right means I'm adding 3 to this. So that's going to be 4, and the y stays the same. All right. 3 up and 3 down. So for these ones, my x's are going to stay the same. I'm going to add 3 to my y over here, which is going to be 5. And then I'm going to subtract 3 over here, which is just going to be -1. And then you can do your best to draw in your circle. Oh, no. Oh, no. That was a little wobbly. Oh, no. Okay. All right. We're going to get through this. It's like the last one, so it's like it's giving me issues. All right. And that circle was very upsetting. It's so upsetting for a geometry teacher not to have a perfect circle, but I don't have a compass, so forgive me. All right, anyway, this one, we're almost done. All right, so we have to pull out our center. So it's always going to be the opposite of what you have in here. So we have a -3 in here. I want a +3 in my center. We have a +1 in here, so I want a -1 in my center. And then we always have to take the square root of this. So our center, or our radius is just going to be 2. So we're going to graph this. So we have 3, -1 over here, 2 to the left, 2 to the right. So our y value is going to stay the same with those. I'm just going to subtract 2 over here. So that's just going to be 1. And then add 2 to the x value. That's going to be 5. You can always just count them if you don't like this method. And then you're going to have 2 up and 2 down. All right, so now the x values are going to stay the same. So both of these are 3. And then we're going to add 2 to this, which is just going to give us 1. Subtract 2 to that, which will give us -3. Connect the dots. Steady, steady. Ooh, that one wasn't bad. Huzzah. Okay. All right. And then last couple of problems. Okay. With this one, if we just have x squared and y squared, what is going to be our center? So obviously we didn't subtract anything. So for these, our center is just going to be 0, 0. And then our radius for this one is actually going to be the square root of whatever 12 is. But now since we went through that whole thing of simplifying radicals, we should know that we can simplify this one because it has a perfect square of 4 in there. And then the square root of 4 comes out as a 2, and then the square root of 3 gets stuck. So our radius is actually 2 root 3. All right, last one. So the center of circle S is 9, 2. And the radius of the circle is 5 units. So which point is on the circle? So remember what we did up here, we had to either have the same x value or the same y value. So this one we had the same y values, this one we had the same x values. So they either have to have an x value of 9 or a y value of 2. So the first thing that we can do is cross out this guy because that one does not make any sense. So these have an x value of 9, this one has a y value of 2. All right, so let's start with these guys. So if it has an x value of 9, that means the y value should either be adding or subtracting 5. So 2 plus 5 is going to be 9, 7. So none of that works. 2 minus 5 is -3. So none of these work, which process of elimination, our answer is going to be A, but let's just double check it. So our y value is 2, which means I either have to add or subtract 5 from the x value. So 9 minus 5 is 4. So this one is indeed our correct answer. And just like that, you are done with geometry notes. Woohoo! All right, enjoy your Friday. Have a fantabulous weekend. I will see you guys on Tuesday.